everyone. Now today I am starting the new practical, that is estimation of water of crystallization in Mohr salt by titrating with KMNO4 solution. Titration. Volumetric analysis is the analysis where quantitative estimation is carried out by measuring the volume of the solution and titrating it against a solution of known strength. Titration is the process of adding one solution of known strength from a burette to a known volume of another solution of an unknown strength until the reaction is just complete. This is the picture that's showing redox titration between potassium permanganate and ferrous ammonium sulfate solution. Here, burette contain KMNO4 which act as self-indicator, where the conical flask contain ferrous ammonium sulfate solution. After adding KMNO4 solution, ferrous ammonium sulfate solution becomes pale pink in color. Types of titrations: acidimetric and alkalimetric titration, oxidation reduction titration, iodometric and idimetric titration, precipitation titration, and complexometric titration. Oxidation reduction or redox titration. In such type of titration, a reducing agent is estimated by titrating it with a standard oxidizing agent and vice versa. Generally, oxidizing agent is used as a standard solution. In these reactions, change in valency of ions take place simultaneously. One substance is oxidized and other is reduced. Object of the titration, that is estimation of water of crystallization in Mohr salt by titrating with potassium permanganate solution. For this practical, chemicals and apparatus are required, that is KMNO4, ferrous ammonium sulfate, dilute sulfuric acid. Apparatus are 100 ml of measuring flask, 150 ml of conical flask, beaker 250 ml, funnel, pipette of 10 ml, test tubes, dropper, digital weighing machine, burette stand, burette clamp, and 50 ml of burette. For lab preparation for teachers. For preparation of Mohr salt solution and KMNO4 solution of different normalities are given here. They can supply any strength of these solution to the students as per a requirement. Theory behind this titration is: titration of Mohr salt with potassium permanganate solution in acidic medium is also a redox titration in which Mohr salt acts as a reducing agent and potassium permanganate as oxidizing reagent in acidic medium. Mohr salt is a double salt of ferrous sulfate and ammonium sulfate having 6 molecules of water as water of crystallization in it. Active constituent of Mohr salt is ferrous sulfate, which gets oxidized to ferric sulfate, while potassium permanganate is reduced to manganese sulfate. Here the molecular reaction between the KMNO4 in acidic medium, which forms potassium sulfate, manganese sulfate, water molecule and oxygen. In second step, where ferrous ammonium sulfate react in acidic medium in presence of oxygen to form ferric sulfate, ammonium sulfate and water molecules. The overall reaction is when KMNO4 and ferrous ammonium sulfate react in acidic medium, it forms potassium sulfate, manganese sulfate, ferric sulfate, ammonium sulfate and water molecule. Ionic equation. First of the reaction is reduction half reaction, which shows gaining of electron, and the second step oxidation half reaction, where ferrous ion is by losing of electron converted into ferric ion. Procedure. Step 1. Titration of supplied Mohr salt solution, that is unknown solution, with potassium permanganate solution. Rinse and fill the burette with potassium permanganate solution up to 0 mark. Pipette out 10 ml of supplied Mohr salt solution into a conical flask and add 2/3 test tube of dilute sulfuric acid. Shake and titrate it with potassium permanganate solution until the color of the solution becomes pale pink. At the endpoint, when all the ferrous ion are oxidized into ferric ion, a drop of potassium permanganate develops pink color. Hence, endpoint is just appearance of pink color. Note the reading of burette. Repeat the procedure with same solution till concordant readings are obtained. First, rinse the burette with water. And then rinse with KMNO4 solution. Then fill the burette up to 0 mark with potassium permanganate solution. Maintain the level of KMNO4 up to 0 mark. Rinse the pipette with water. Then rinse with a known solution of Moha salt. Pipette out 10 ml of unknown solution of Moha salt. Maintain the level and pour this 10 ml of ferrous ammonium sulfate solution into the conical flask. Add 2/3 test tube of dilute sulfuric acid. And then titrate it with KMNO4 solution. KMNO4 is self-indicator. When this transparent color is changes into light pink color, that will be the end point of this titration. Now this transparent color is changes into pink color. This is the end point of this titration. Note the reading. This is 15.7. Repeat the procedure at least 2 times more until you get the matching readings. Reading table. Titration of unknown Mohr salt solution with KMNO4 solution. Volume of Mohr salt solution taken for each reading, that is 10 ml. Volume of KMNO4 used, that is the burette reading, is 15.7 ml, 15.4 ml, and the third reading is 15.4 ml. So the final reading will be 15.4 ml, that is V2. Second step, that is preparation of standard Mohr salt solution of N/30 strength. We know that equivalent weight of Mohr salt is 392.1. Amount of Mohr salt to be dissolved in 100 ml for N/30 strength. We use the formula W is equal to NEV upon 1000, where N is normality, E is equivalent weight, and V is volume. Normality is 1/30, equivalent weight is 392.1, and the volume is 100. So finally we get 1.307 gram weight. So weigh accurately approximately 1.307 gram of Mohr salt and dissolve in water in 100 ml of measuring flask. Add 1 test tube of dilute sulfuric acid and make up the volume with distilled water up to the mark and mix well. This is the picture showing how to make a standard solution of ferrous ammonium sulfate. Now prepare a standard solution of Mohr salt. First, weigh 1.30 gram of ferrous ammonium sulfate, that is Mohr salt, now this salt is transferred into clean 100 ml measuring flask. Pour little amount of water from all sides of funnel. Dissolve this 1.30 gram of Mohr salt properly. And then add 1 test tube of dilute sulfuric acid into it. And then make up the volume by adding more water. up to this mark. Shake well to make it homogeneous solution. Now this is N/30 solution of ferrous ammonium sulfate. The third step is titration of prepared Mohr salt solution, that is known solution with KMNO4 solution. So pipette out 10 ml of prepared Mohr salt solution into a conical flask. Add 2/3 test tube of dilute sulfuric acid. Shake and titrate it by adding KMNO4 solution drop by drop from the burette with constant shaking until the color of the solution becomes pale pink. Note the burette reading. When a permanent pale pink color appears, repeat the experiment to get matching readings. Shake it well and take out 10 ml of this known ferrous ammonium sulfate from pipette. Pour this 10 ml of ferrous ammonium sulfate into clean conical flask. And then add 2/3 test tube of dilute sulfuric acid. Now titrate this reaction mixture with KMNO4 solution. Add KMNO4 solution from burette drop by drop until this transparent color changes into light pink color. Now this transparent color changes into light pink color. Note the reading. Note the reading, that is 15.0. Repeat the procedure at least 2 times. Reading table. Titration for known Mohr salt solution with KMNO4 solution. For each reading, we have taken volume of Mohr salt solution is 10 ml. Volume of KMNO4 used, that is burette reading, is 15.0 ml, 14.8 ml, and the third reading is also 14.8 ml. So our final reading is, that is V1, 14.8 ml. Calculation. Formula used to calculate the strength of supplied Mohr salt solution is equal to 10 into W into V2 upon V1. We know that where W is weight of Mohr salt, which is equal to 1.307 gram. V2 is 15.4 and V1 is 14.8. So input all the values of these in the given formula. Now we have calculated the strength of the supplied, that is the unknown Mohr salt solution will be equal to dash gram per liter. The second calculation is water of crystallization in given solution of Mohr salt. We know that molecular mass of ferrous ammonium sulfate is 392.1, where water of crystallization is 108. So input these values into the given formula, that is weight of crystallization of water in Mohr salt multiplied by strength and divided by molecular mass of Mohr salt. Input all the values, that is 108 is weight of water of crystallization in Mohr salt, that is divided by molecular mass of Mohr salt, this is 392.1, and multiplied by strength, which will be equal to dash gram. Now finally the result is strength of given Mohr salt solution is dash gram per liter, and in it water of crystallization is dash gram. Precautions during titration. First, rinse the burette and the pipette with the solutions to be used in them to avoid dilution with water. The burette stopper must be tied to avoid leakage. Remove the funnel from the burette before titration to avoid an increase in the volume of the solution in the burette. Only one specific reaction should occur between the titrant and the analyte. There should be no side reaction. Viva voce question. The first question is, what is Mohr salt? Answer is, ferrous ammonium sulfate is called Mohr salt, that is double salt. Next question, what is the total number of water of crystallization in the formula of ferrous ammonium sulfate? Answer is, the water of crystallization number is 6 in the formula FeSO4 NH4 का whole twice SO4 into 6H2O. Next question, what is water of crystallization? Answer is, water of crystallization is the fixed number of water molecules chemically attached to each formula unit of a salt in its crystalline form. Next question, name any self-indicator, that is potassium permanganate. Next question, does the equivalent weight of substance is fixed or depend on chemical reaction? Answer is no. Equivalent weight of substance is not fixed. It depends upon the chemical reaction. For example, equivalent weight of potassium permanganate is 31.6 in acidic medium, while it is 52.7 in neutral medium and 158 in alkaline medium. Next question is, why standard solution is prepared in distilled water and not in tap water? The answer is, standard solution is prepared only in distilled water because tap water contains ions like chloride, calcium, magnesium, etc. and make the solution turbid and may interfere in titration. Next question, why dilute sulfuric acid is added while making standard solution of Mohr salt before adding water? Answer is, since ferrous sulfate, a constituent of Mohr salt, may get hydrolyzed by water to give ferrous hydroxide. So, dilute sulfuric acid is added before adding distilled water while preparing its standard solution. Dilute sulfuric acid checks hydrolysis of ferrous ion of Mohr salt solution from undergoing oxidation to ferric ion. Next question, what is equivalent weight of Mohr salt? Answer is, since Mohr salt is reducing agent, its ferrous ion during redox reaction is oxidized into ferric ion, and this process involves transference of one, that is loss of one electron only. Hence, its equivalent weight is molecular weight upon number of electron lost or gained, that is 392.1 divided by 1, which is equal to 392.1. How to write practical in a practical file? First, write object and then write apparatus and chemicals required. The next step will be theory of titration with reactions. Then write procedures of all first, second and third steps. Then write observation table and finally calculate the calculation by using the formula. Lastly, there will be result and the precaution. Thank you. If you like my channel, please like, share and subscribe.